Okay, test. That sound seems to be working. Twitch seems to be working. Perfect. Hello, everyone. Welcome back to the stream. So, last week, we mostly worked on the parser and the AST. Most of the work we've done was to define those structures that represent the shape of our program after parsing. Most of it was the top level declarations and statement. What was missing was the expressions. And on Thursday, we spent some time um, fixing the grammar of the language, fixing the parser to make sure we had no ambiguities left so that we could parse confidently. There's only one left, but it's for something that doesn't matter because it represents a case that cannot happen in practice. And so today, what I'm hoping to do is I'm hoping to be able to finish defining the rest of the AST, even if it's not perfect, even if it's just a first pass, a first draft, so that we can move on from the parsing and start doing other things on Thursday. And on Thursday, if we manage to do everything I want to do today, either we will move on to semantic analysis, some of the compiler phase, like renaming, type checking, that kind of stuff, or maybe I'll tackle some of the bytecode stuff just to do something a bit less compiler and a bit more Pete specific for a change. I'll see what the mood is like on Thursday. But for now, let's go back to our AST and let's go back to the parser. So, last time where we left, we had, so here on the left, we had defined all of the grammar of the language and how to construct the AST based on the things we have parsed. And we were left at expressions for which we had not defined anything, hence all of the undefined. And here, I don't know, come to think of it, if I want grouped expressions, which is parenthesis, to be part of the AST. And I don't think I do. A big thing that I think is important to mention, two things that I think are important to mention. Um, I don't want to, like, the scope of this project is already pretty large. For a toy project of a toy compiler, there are a lot of things in the reference of the language that are pretty ambitious, such as, generic arguments for data structures and functions and everything. I don't want to go slightly beyond the scope of this, so there are a few things I am not planning to do in the first draft of this, in the first iteration of this project. One such thing is I'm not planning to have the AST be bidirectional, as in you cannot reconstruct the exact source code from the AST because in the process of constructing the AST, we discard a lot of information about white space and all of the comments, and also the way literals were represented. We already translate them. At some point, if we wanted to fix that, we could change the way locations are implemented. We could change what amount of information is stored in tokens. We could try to make the AST bidirectional so that we could implement a reformatting library, like program based on this AST. That is not a goal I have at the moment. Again, I want to have a first iteration in which we make things work, and then we can come back and improve. Another example is, for now, error messages for the lexing and parsing are extremely bad, and at some point in the future, we'll go back and we'll fix that. But for now, I want to iterate, even if what we do is not perfect on the first try. So, let's see, of all of those things, which ones are relevant to add in the AST. So first, grouped expressions I don't think are something I want to do. I think those are just here for the purpose of parsing things, and I don't think they need to be present in the AST at all. So an expression will be, and here we're probably going to be simplifying it a tiny bit in the sense of we're going to flatten a few things that here have layers of indirection. So first, we're going to have a path expression, I suppose, which would be a potentially qualified path to an identifier. Identifier which could be a constant, a function, a variable, anything else. At this point, we only have the name. Resolving this will be one of the first things we do during the actual semantic analysis. At this point, during at this stage, we're gonna have our extension here for the moment, and the path expression is going to be. It's gonna be probably we should define a specific type. Let's define. Let's say we have a type path that we haven't defined yet. Let's do that path info to be consistent with our naming convention so far, which is going to be path info. I'm just gonna do that as well. Oh, that's already done here. Path info will be what is relevant to a name that appears in the thing, and that's going to be I'm jumping right into it, but as usual, any question, please do ask. I'm always happy to interrupt anything I'm doing to answer questions if anything isn't clear. So I guess the obvious thing will be in the path we need. For now, do I want to make this? I'm going to make it directly a non-empty list of identifier, which is going to be the list of the different names of, like, if the thing is qualified, if a qualified path separated by the colon operator. It has to be non-empty because to be a valid path, it needs to contain at the very least one name, which like just the local name of the thing. And what do we have? We have maybe a path expression, or maybe generic arguments. We have encountered generic arguments before. How have we represented them? How have we represented generic arguments before? In the case of a structure, those were always just names of arguments. Here, they could be actual. They could be actual types, and we have not defined what a type is. Okay, so we're gonna have to define that first. Although I guess for now I can just link to the type, and we're gonna define it later. So this would be how we recalled this in the past. Params. Trying to be consistent in my naming. So those are an optional list. I guess I could just do a list and leave it empty of type expression. I could do it as a maybe non-empty list, which is the same thing as a regular list, but the types being slightly different conveys a slightly different meaning. But I think for now, just list is fine. So this is going to be a type expression, which is a type we haven't defined yet, but that should be enough. Okay. So here, but type expression, this isn't what we're doing. We're doing path expressions. There we go. I guess then for grouped expressions, we're just going to return the actual expression unchanged. So again, if you were not there, I am using happy, which is the Haskell equivalent of flex or bison for C and C++, which is like parser generator. I describe the grammar of my language and it generates the parser for me at compile time. And here in between the brackets, I define if we've matched this particular rule of the grammar, how do we construct the corresponding AST thing or whatever we want to construct. So here, between parentheses, an expression will just be forwarded as just like back to the higher level. We don't need to represent the fact that there were parentheses in the AST. The shape of the AST will convey that for us. So here, what I want to do So here, a grouped expression that is just we return the thing as it were. So here, this is going to be a path expression will probably return a path info, our new type. If it's just an identifier, that's a path info that is constructed with just the identifier and an empty list of type arguments. If it's identifier and arguments, that's basically the same thing. Except we're gonna give the list of generic arguments as here $3. And here, oh, actually, this would need to have the location as well. Oh, interesting. So I need to do, I'm going to introduce another function. I guess it's just, yeah, first. I don't need to introduce a new function for this. So here, I always want, so here at the moment, all my tokens share, contain their location information, which for now is just like byte index, oh, no, sorry, code point index in the input stream and a row column, nothing more, an actual span or anything like this, but good enough for a first iteration. And I will want a lot of my ST to contain the location, at least at first, at least during the first phases of the compilation. So here I will need this to return the location. So I need to make sure that I can extract the location from this. Here the identifier is a token specifically, and I can get the location information out of it. It's going to be first of $1 to get the location information. There we go. Same thing here. First of $1 and then the path info. And here is the interesting case. We have, which is rare in this case, we have right recursion for our grammar here because this is one of the parts that was ambiguous with left recursion. So here we have already encountered this path expression is like a right recursion. We already get a location and a path info out of it. And we're going to have to deconstruct, reconstruct to add this new identifier at the beginning of it. So things are going to be somewhat similar because we're going to get the location of the identifier, but we are going to create a new path info. I'm going to make a new function for this just to keep this not too cluttered. Prepend path info of get raw identifier of $1 and the actual thing, which is going to be second of $3. So the dollar things refer to the different parts of the match. So here $3 will be this path expression, which is itself a tuple location path info passed. Okay, so I'm missing just a function, prepend path info, which is going to be a regular Haskell function that, given an identifier and a path info, returns a new path info. And given some prefix and a path info that I'm going to deconstruct, we'll return a new path info in which we append this prefix, well, we prepend this prefix at the beginning of the path name. This is not the correct syntax. I'm going to fix that in a second. And we leave the path params unmodified. Okay. So I guess I could instead... Yeah, I could change this. I could simplify this. This is going to be... yeah, I have something very similar here, actually. I should probably harmonize this and call this prefix as well. So this is gonna be a lens as well over the path name do prefix. However, this is a non-empty list nonetheless. Let me quickly have a look at scale non-empty. I never remember what the constructors are. It's this one. Okay. So here, prefix, just, I think prepend is actually better. Let me fix this. Which means I have to go find the other use of prefix and change it to prepend. There we go. Okay, so that deals with our path info, which means we are done with path expressions. In the case of a path expression, we can return so here the location, this type is probably going to be the location like it is for everything else for now. That means we are going to need to return, because here the path expression gives us a tuple location path info parsed, and we want to return a location and the expression parsed, which means we want to combine it. How do I want to do this? Or do I want to do this at... No, I don't want to do it at this level, because this requires the recursion. So I want to construct it at this level. This is going to be basically... Sorry about that. I need to just quickly do some moderation. 1 second. There we go. Okay, let's resume. So here, what I have. Here, my $1 is going to be a tuple of location and expression passed. And I'm going to want to... probably do something like this to then return the same location, but however, I need to return a path expression, the same location for now, and yeah, I think that's the simplest way to express this. Or there's probably like a more concise way. This is probably the cleanest way. Now, we are probably going to be able to do better for other expressions. Here, the fact that we have this right recursion and we need to return not an expression makes this a bit more complicated than it needs to be. Okay, next, a field access expression. What's a field access expression? It is expression dot something. So it's going to be a struct dot a field, or call of a function that returns a struct dot a field, something like this. So this is going to be, if we define it here, a field access expression. Again, I'm storing for now those extension types. We are going to filter them later. Oh, however, yes, I have not named them. So this would be correct, I think. Yes, I think so. So what's in a field access expression? That's just two other expressions? No, it's just an expression and an identifier. Do I want to make a dedicated type for this? I don't think so. I think saying just this is an expression and an identifier. I think that's good enough. Which makes it a bit easier. So here we can probably just return the result unmodified. And that means here this needs to return the tuple, location, and expression passed, which is going to be $1 is going to be an expression, so it's going to be a tuple of location expression. So I'm going to do the same thing I've done here. And yeah, there we go, that's correct. We decompose the expression that we got, and our result is this is a field access expression using the location as the first argument, and the second argument is the expression. The third argument is get the identifier from $3. Okay. Next, what do we have? We have a call expression. Which is a function call. And here we have something a bit simpler. We have we have a path expression. Do I want to store that as a path info? I think I do. I think it's easier rather than storing it as an arbitrary expression. Since the reason we have this is because we do not have any ability at the language at the moment to pass functions arguments or return functions from other functions, which means the only way to call a function is to refer to its name explicitly. Yeah, I think it's fine to do this. So a call expression will be something that takes a path info, or maybe for a function call. Maybe for a function call I want to define. No, I think I'm fine with just like defining it in line like this. This is a path info, which is the name of the function. And this is then a list of arguments, which are themselves just expressions, basically. So here, again, we're going to be returning the location as well. And here we have the path expression, which gives us our path info and the location that we need. And we have an optional, a maybe list of expressions. So here, I want to keep the location here as well. I've been a bit inconsistent with my handling of location so far. No, I don't. It will be contained. It will be contained in the actual, so I don't need to keep it there, which means it's fine for this to return to discard. Why am I making expression? Maybe, okay, let me take a second to think about this. Here, I've made expression give me the location. Why have I done that? Oh, I think it's because I have a few places where I actually need to get the location. Yeah, I don't see any easier way of doing this. For now, let's keep it that way. It's a bit more verbose, but that's fine. So that means here a call argument can just be, hello, doing better, thank you. Because yeah, if you haven't watched the stream, last Thursday was rough. It was a short stream. I managed to go through it, but it was not wasn't at my best. But thank you. But yeah, here we can just discard the location information and just return the actual expression. And here, so here we have the path expression, which is our path info. which is grouped with the location. So we're going to do the same decomposition. So we have the path info and the location information in $1, and we create a tuple, which is the location, and a call expression, which contains the location as well, contains the path information, which is the path to the function, and the list of arguments, which is going to be, I'm going to do a fold of this maybe of list, and it's just going to give me a list and just the empty list if the maybe is nothing. So that's fold of $3. Okay, that should be everything we need here. So that's call expression handled. So here, this is just $1 as well, nothing specific to do. Array expression. Array expression is the thing on the left is... Oh no, array expression is an array literal, not an array indexing. So that's just a literal array. How do we represent that? That's just gonna be a list of expressions, I think. There's nothing more we need to do at this point. Which means that should not be too difficult to do. This is gonna be... here we're gonna have the convenient thing where I can here get just the expression discard the location, because here the location will be obtained through this token, which is the opening brackets. Which means here, this is gonna be an array... Actually, I need to return the location here. However, but the location is just gonna be $1 because tokens like this give me their location directly. And the expression will be an array expression that also has the same location $1, and it will contain the list of the expressions in the array, if any. And that is gonna be, again, it's an optional list, and that's gonna be a fold of $2. Okay. Next, we have the index expression, which is, let me check back here. Yes, so here we can just return $1 as well. Next, we have the index expression, which is indexing something in an array, which is going to be, therefore, the expression on the left, which we expect to be of type array, and is something that the type checker will have to check, or at least something indexable, which in our limited language is just an array, basically. Or vector, I think I've named in the reference for the language. It's a bit high. And the second thing is, for the index expression, is just the other expression, that is what is between the brackets. Okay, so this is just two expressions. We apply the same thing. I could almost just fmap stuff there. It might be more readable to do it the explicit way. Let's decompose location and the expression 1 from $1. And our result is that location and an index expression giving the location as first argument, and second of, well, the expression 1 here, and the second part of the expression 2, which is $3 here. I guess I could rewrite this actually as not decomposing here, but this is first of $1, and this is second of $1, and this is also first of $1. Yeah, that feels. I think that would be correct. This would be passed as the left hand side would be passed as an array expression. So as a array literal, and then this would be passed as an index expression in which the left will do a test. One thing I'm hoping to accomplish this evening is if we manage to finish defining the AST for expressions and finish the parsing and arrive at the point where it seems to be working, I want to write some tests because we have very little automated tests for now. The very little we have just don't actually pass. I want to start writing some tests, and testing something like this is a very good idea. But yes, it should work. However, at this point, since we are just doing parsing, if the thing in the brackets is a string literal, that's perfectly fine. That's an expression. The type checker has not run yet. It will run at a later point to check that like the index is something that makes sense. Okay, so that's index expressions. Struct expressions. So this is likewise just forwarding the result of here. What's a struct expression? So it is the construction. That's a good question. Well, I mean, it's different, right? That we have the two things. We have constructing a type from its name, which is the struct expression, and we have constructing a vector from just a literal, which is that syntax. You're right, however, that it requires type inference, but that's not the end of the world. We're going to have to do some type inference anyway for the type of expressions, but our type inference is going to be extremely trivial given the fact that there are no ambiguities in literals. Since we have no support for floating point values, we have only one numeric type, which is int. This is going to make type inference a lot easier. But yes, we're going to have some amount of type inference. So a struct expression is creating a struct based on its name and then giving the list of the fields. There again, there isn't going to be any type checking because this is not the part where we do that. So this can just be translating it there again, I think, path info and list of expressions. No, expressions. It's going to be a list of tuple name expression. Okay. A struct expression. I have that thing where Twitch is complaining about my bit rate being unstable again. And I'm not exactly sure why. My OBS is just configured to be at the max bit rate. If anything is weird, let me know and I'll investigate, but I've looked at the recordings and it's been fine so far. Hey, how are you? Still parsing, yeah. I'm hoping. So the last week was mostly defining the top level structures of the AST, and on Thursday making the grammar unambiguous, going through all the shift reduce conflicts and fixing them. We have one left that is benign and that I decided to just leave in. And this evening is trying to finish defining expressions so that we can be done with parsing, even if things are a bit rough and like improvable, locations are bad, like even if things are a bit rough, trying to get something out. And my goal for this evening is to then again finish parsing, finish defining the AST, so that I can start defining tests, because we don't have a lot of tests at the moment, and being able to test interesting combination of like syntax will be, I think, very useful. So that's my goal for this evening, so that next stream, probably Thursday, we can start either doing some of the compilation phases, the semantic analysis, renaming, type checking, that kind of stuff, or maybe I'll take a detour and I'll start doing some of the less compiler, more Pete stuff, like the bytecode translation into image at the end of the chain or something like this. I'm not sure yet. We'll see what I'm in the mood for on Thursday. But yes, this evening, still passing. So here, a struct expression just going to be the path info on the left, which is the name of the structure. And here it's going to be on the right a list of tuple identifier expression. Which means here, field expression, this is going to be a tuple identifier expression passed, which here is going to be get raw identifier of $1. And here I can discard the location information from the expression. So it's going to be second of $3. And based on that, I can define this struct expression, which is going to be, again, a location and an expression. And this expression is going to be the path expression gives me the location, yes. So I can rewrite, I can do this as being the location is the first of the tuple of $1, which is this path expression here. And the actual expression is it's a struct expression with the location again, so again first of $1. And the path info is second of $1. And the list of tuple identifier expression is just literally $3. There's no need to do any translation here. Okay. So that's struct expressions handled, and we can go back here and make that $1. Then we have literal expression. So here, I don't think I'm gonna introduce a layer of indirection, so we're gonna just like inline them. What kind of literal expressions we have? We have literal int, character string, and booleans. That's all we have. Do I want to have a different extension type per type of literal? Probably not. So this is going to be just a boolean, I guess. I should probably... Yes, I should probably be more explicit like this. And we're missing one, which is the character literal. And just for now, I'm gonna do that. And I think I've used text in my tokens. Let's have a look. Yes, I've used text. Okay. Yeah, at the moment here, the expression. So I'm using the trees that grow approach, where I have like this AST phase as my argument on all my AST types, and in every branching thing, I have like those extension types in the constructor. And for now, all of them for the first phase, which is parsed, is the location information, rather than the location being stored like within the actual structures, which means I can discard the location information as I move on through the compilation phases. Is that the best? I am not entirely sure yet, which is why I've been insisting on like, I am doing this first iteration. maybe I'll realize this is the completely wrong way of storing location information, and we'll just have to change that. But for now, I think that's good enough. And I'll see if it's wrong. But yeah, at the moment, the extension types all contain location for the first phase, which is parsed. So expecting, like, for now, maybe there is no point in having such like a extremely fine granularity in extension types. Maybe I'll realize there's no need to do something like that. But for now, I'm doing something kind of generic that I know is, if maybe overkill and imprecise, not wrong, and we'll refine afterwards. I will probably actually need to go define those things. I haven't defined them yet, but I'm going to do that in a second when I'm done with this. So here, I'm going to need to define. So the problem here is, yes, it's something I have mentioned as well. Yeah, again, in the spirit of, I want to get something that, like, I want to iterate and get something that works first. For now, my location information is not byte index, but code point, Unicode code point index in the input stream, and row column, basically. That's all, nothing more. But definitely something we're going to want to revisit at some point, and probably have like the full span. And I was mentioning as well, for now, my plan is to have the AST not be bidirectional. Like, you cannot reconstruct the exact source from the AST, because we discard white space information, we discard comments, we discard that kind of stuff. So we would not be able to make a code formatting tool using this AST library as it is. And that's not something that is a goal of the project, but would be, I think, an interesting stretch goal if we come back to revisit this in the future. Something that we will revisit, not as a stretch goal at some point, is error handling, because at the moment the errors are just extremely bad, and having something that handles them properly and have like proper, clean error messages. And it might be something that forces us to redefine how we deal with location. But yes, for now, location is just code point index, row column, basically. And column, I've mentioned that in the previous stream, but trying to determine the actual column index as an ID would see it based on a number of Unicode code points. It gets tricky very, very, very quickly, because not all code points are like, one column can be multiple code points, and one code point can be multiple columns. Yeah, exactly. You have to have a very, very, very specific AST that contains all of that information. It is an AST, maybe not the AST that the compiler would otherwise use. But yes, that's why I consider having a bidirectional AST to be kind of a stretch goal. It is one of the reasons as well why I'm using a syntax based on Rust for familiarity, but also because that way, since I'm basing my fake language on a language that already exists, I get the formatters for free, basically. A Rust formatter should work on our language just fine. Yep, yeah, exactly. I'm not the compiler. An AST, but not the compiler AST. Okay, so here, what were we doing? Oh yes, the literals. Yes, I'm gonna need something. Since my tokens on which I match are a tuple of location and the actual token value, if I match int, character, string, and something, I didn't expect those to show up. If I click it, will it clear it? Perfect. So since I'm going to match on the entire thing, including the location, that means that here, when I get a $1 something that matches the thing that I have matched, I will need to re-deconstruct the token type to get the actual literal int or something, which is a bit annoying, because it's like I have to do a potentially... That's a good point. It's something that I will need to try. Like, it's some I try to conceptualize all of the parts of the projects ahead of time so that I would know exactly what code to write while on stream. There are a few things like this where, like, I don't have a clear idea for how to do this, and we'll improvise it live and see where the code guides us basically. But that's not a bad idea. Could probably be doable. Another thing I was thinking was also to just like have each token contain the white space and comment information of everything that precedes it. Because since I have an end of file token, which is a special token to indicate we're done passing, that means every white space could be covered by just the next token. And if we store like that in each token what came before, then we don't have to change anything about the parser, but maybe we could do something as well, where like the AST stores the exact chain of tokens that were in the input. Like we could envision a bunch of other ways of doing this, and again, it depends on what we're trying to accomplish. For now, first iteration, I just want to pass, basically. And so back to this, I'm gonna have to do, so here is the raw identifier here, where I have to re-deconstruct the token after matching it the first time. I'm gonna have to do this for all of my literals. And this is where having proper error handling would be good, because this is not good error handling. So this is going to be... Actually, I probably want, in the case... In the case of literals, I probably want to actually keep the location information in the tuple, since expressions are all prefixed with their location. So here I probably should change this to... to just be location int. That's a fair point. But like it's a low bar. Not deleting the source file on air is a low bar. I'm happy we were crossing it. I mean, I think we don't have tests, so maybe we don't. But it feels likely that we're not modifying the raw source file here. Ah, yes, Haskell. No side effects, all pure code. We'll just happen to delete your files. The compiler will delete your files. It's fine. Is it called tint? It's the thing. Well, the thing is, we do have the buffer, and therefore having the location currently has the code point index, so basically the array index in the actual source file. So we could already reconstruct a few things. This has just been a matter of actually, doing it. Literal int. Go back to here. So I guess I'm going to rewrite this as instead an fmap case, because I want to keep the location here. And I can do that 2 more times. Actually, I can do it with just... I think that's correct. Is it literal? I think it is. It is. Okay, perfect. Except this isn't a string, this is text. Okay, so now armed with those helper functions, we can go back to here. So a literal expression will be here int, I will match the location, and so I will do a get int on $1. That gives me a tuple location int, and I can uncurry int literal expression, and call that, so uncurry transforms the function of two arguments into a function that takes a tuple. That's a good question. Let me check the reference. Do we support bases other than 10? What did I write in the reference document that I wrote before writing a single line of code? Int, let's go to literal. It's not very useful. Integers, we support decimal and a hexadecimal. So 2 bases. And I think we have left a few things undefined in the lecture. If I remember correctly, we've done passing integers like both like decimal and a hexadecimal. We haven't done some of the character interpolation in strings, I think. I think specifically the Unicode and ASCII \x\u, I think we haven't done. But here, so yes, I'm transforming this constructor, which is a function of 2 arguments, into a function that takes 1 but a tuple. And I give it the result of calling getInt on my $1, which is the match of this token here. I can do the same thing here, but with not int. And the same thing again. And finally here, another thing I've mentioned in the previous stream as well, something I've done on purpose. The reference document is extremely ambitious. There's a lot of things I want to cover in the first iteration of the project. Again, there is like generic arguments, template arguments, if you will, like generic types, generic functions, despite like the fact that the target language is very limited. So very ambitious language things. I didn't want to like be restricted to just like ints, but there are things that are deliberately missing in the reference of the language at the moment, things that would not be difficult to implement, but I have chosen to keep out at the moment. And well, that's your question about RFC proposals, wishes. It tunes perfect, like it perfectly goes with this. I want, when I'm done with the first iteration, when everything that is currently in the reference is implemented, I want to add more to the language because I think it's a very different kind of workflow to add something to an already existing language rather than adding it as part of the original development. Like, okay, we have a thing that works. It has tests. It has like not really users, and that's not going to be the case here, but you know, it has a canonical version. And how do we add stuff to that? An example for something I have kept in mind as like an extension to the language, and everything we are currently doing is done like months from now. Tuples. We do not have tuples in the reference document for the language at all. This is not something that I have planned in the language, but adding it in a subsequent iteration of the language would be a very good way of doing, you know, kind of a practice run of like, okay, let's write an RFC, let's see what the impact is going to be on the parser, let's see the impact, let's see the workflow of modifying an existing language in comparison to what we're doing right now, which is writing something from scratch. And to answer your question, yes, I will absolutely welcome RFC proposal wishes. And I think issues on the GitHub page are the right way to go about this. For now, at least for the upcoming months, the plan is for me to not accept code contributions because the goal is for me to just do this thing live. If I start accepting, you know, PRs on GitHub that implement half the stuff, it kind of defeats the purpose. And like some of it is also a challenge for me, right? Like I've implemented compiler and things like this before, but doing the whole thing from scratch is a bit of a challenge. So it would be a bit cheating / defeating the purpose to accept code PRs. So for now, my policy is like issues welcome, code PRs will be rejected. When we get to 1.0, when the language when the language gets to a point where we can start iterating on it in a more like at a higher level, then maybe I'll revisit this stance on not accepting code contributions. But if I do, then I'll first start by writing like a code of conduct, like all of the things that are required to have a proper contribution guideline, which are not there at the moment because at this stage, so early in the project, that's not a thing yet. What do you mean security related topics? I'm interested. Oh, interesting. Interesting. I am not. Security is not a. I mean, I have like the base knowledge of having worked in tech for a while, but it's not a topic I am extremely familiar with. So that could be something interesting to explore as well. Okay, so that's literals done. And now the last thing we have to do, this is gonna return the location as well, meaning that here above we can forward this. The last thing, I'm just gonna preemptively do that as well. The last thing is we want to do operators. And likewise, here we have like a separate grammar rule for them. But I am going to here inline them into the expression type. Excuse me. So what do we have? We have a reference expression. So we don't have pointers in the language at all because there is no heap in Pete. So we are extremely limited by what we can do. And I thought about whether it would be possible to implement pointers by using them as like a stack index, basically. Like, oh, pointer 3 means this is the third value in the stack or something. But that would put so many constraints on like stack reordering things because every time we reorder the stacks, we would need to go modify the pointers in the stack. That would be a nightmare. Because that would means basically it would mean we would need to keep in the stack a list of the pointers that need to be modified in the stack. Absurd. So I decided that like too complicated. There are not gonna be pointers in the language. However, reference expressions are a thing because I want functions to be able to say this argument is taken by value or is taken by reference. And the difference being, do we copy the value on the stack or do we just like reorder the stack so that the actual value is passed as an argument? And therefore, we need reference expressions for that. Actually, wait, no, do we need reference expressions for that? Could I just give the value? No, I think it's better to make it explicit rather. Yeah, but again, the implementation details of like when you only have a stack and a very, very, very limited number of stack operations as your backend, implementing pointers is a nightmare. Which is why I'm not gonna bother. Everything is gonna be like not just like passed directly by just putting it on the stack. We could consider an RFC to extend the language afterwards to simulate pointers on the stack, but that is something for which if someone is willing to implement it, maybe I'll let them do it, but it feels monstrous. If our backend was a bit more permissive, like if our target was white space, for instance, that would be doable. White space has a heap. So we could do that. But if we're targeting Pete or even more restrictive languages, not really. Um what was I doing? Reference expressions. Yeah, I think it makes sense to have them. I was thinking of like, do we need to do that? Could I just decide that like kind of like in the C++ syntax, you just give the argument to the function and it is passed by reference if needed. And I think it's better to have the reference be explicit. So that means here, this is going to be an X reference. That would mean modifying the image, which I don't think. Yeah, I don't think we can do such a thing. I mean, we could re-implement a Piètre interpreter that has extensions that allow modifying like arbitrary things like this. By default, Piètre interpreters do not allow modifying the image, and the only thing you have access to is like push pop on the stack, basically. Which is why, again, I've defined the language with those restrictions in mind. Already supporting arbitrary sized types on the stack is going to be complicated, because it means if I want to access the third value on the stack, I have to roll it by a number of cells, which I don't know at compilation time, because some values will be taking a a runtime determined number of cells. So there's already a lot of complications there. And that's why, again, I've decided no pointers was an acceptable cutoff point, because they would need to be pointing into the stack, which is something that's going to be modified over time. And therefore, anytime we change the stack, we would need to go change the pointers. And that's. But again, yeah, we could use an external storage, but that's not something that Piètre allows. So if we're sticking to what Piètre allows, can't really do that. What do you mean it's Java? Do I want to align all of this? I probably want to align all of this. That's a very peculiar thing of mine. I really like vertical alignment of things in data structures. I feel like it really conveys the structure of things often. Yeah, you're not wrong there. Okay, so reference expression, that's done on this side of things. Here it's gonna be relatively straightforward, because that's a very good point. That's a very good point. And I have very different opinions on code formatting on projects where I work alone versus projects in which I work with other people. And I don't use a very like intrusive formatter for my Haskell code when I work on my own projects. I use stylish Haskell with minimal configuration, because I like to be able to do such a thing like vertical formatting, clearly like have the structure of things being very visually represented in the code. However, the second I'm working on a team that has more like more than two people, formatter on the code. It doesn't matter which one it is, as long as everyone uses the same. Uniformity is a lot more important than those concerns. Those concerns I only care about because I am a solo developer on this project. And I absolutely agree that vertical alignment with diffs, yes. But yeah, I like formatters on project. Yeah, that's exactly that. I don't like a lot of the choices of Ormolu, and I like that Formulu exists. It's if you're not familiar with this, it's great. Ormolu arrives and decides we're gonna define the one unified Haskell formatting thing better than all the previous formatters, and that way everyone uses the same thing, which I have no problem with, except they chose something that had never been done in the history of Haskell, basically. And immediately a fork arrived, Formulu, because like, hey, we like your idea of having a unique format, but we disagree on what the format should be. Like textbook XKCD, we have 15 standard, we need to introduce a new one, and now we have 16 standard. Fantastic. I love it. But on principle, I absolutely agree. It doesn't matter which formatter a team chooses, but as long as like there's more than two people working on the project, formatter the same for everyone, everywhere. You never want to have to argue about formatting. You never want to spend your PR review. Formula, it started for this, yeah. It started with like we want to have four spaces instead of two, which was why the four in Formula. But it is also more configurable. You can define, for instance, to have commas at the beginning of the line like this, which is the standard Haskell organization thing. While by default, Formula would format this with commas at the end of the line. Like again, in a project that has more than two developers, I value uniformity a lot more than I value the aesthetic. So Ormolu would be fine with me, but at a personal level, yes, I find the style that they've chose for Ormolu to be displeasing. I don't like it. Which is why, for my own personal projects where I'm the only person to work on, I use stylish Haskell with minimal configuration because I then can format things the way I want. We're done with reference expressions. No, we are not done with reference expressions because here we need to return a tuple, the location we get from the actual token that we match, and we get here the path info. I mean, bike shedding is universal. No matter what language, no matter what technology, people are going to argue about the details. Such is the nature of human beings. Like everything can be nitpicked. You're not wrong. Haskellers love to nitpick. It's something of like, I've noticed an evolution in my own personal opinions on this, where like I cared a lot more when I was younger, and the older I get, and the less I think it matters. Or rather, I think the more I have some distance from all of those things that I used to care deeply about, because it's not, it's not really the thing that matters overall. What do we have next? We have negation expressions. Me saying that I have changed opinion with time, it does not mean that it is the correct path. And if you're not on this path, you're wrong. Everyone is like, I don't think there's a right or wrong way to. I guess there is a wrong way to approach this. If you like have broken friendships and lost jobs over formatting debates, you're doing it wrong. But otherwise, I don't think there's like wrong level of caring about this. I, I mean, in Haskell specifically, there's like the whole write everything point free phase that every beginner goes through, and I will confess that even with like at this point more than 10 years of Haskell, probably more than 12 years of Haskell behind me at this point, there are still times where like, oh, I could rewrite this in fully point free if I just use the Blackbird operator. It's always that temptation never completely goes away. I think my custom prelude that I copy from project to project. Yeah, it has the Blackbird because of course it has the Blackbird. Negation expression. Ooh, that's something that we could consider. No, we cannot do at this point. But constant folding is definitely a thing we'll do. I was wondering how many of the optimizations we want to do at the AST level. Like we could do a lot of like simplifications just by AST rewrites, basically, because I thought a lot of optimizations would make a lot more sense at the IR level. And we already translated into something a lot simpler. But maybe things like constant unfolding can be done at the AST level. I think GHC does that as part of the renaming type checking phase. There's the simplifier, if I'm not mistaken, that does some of that work. So I guess you could do some optimizations like constant unfolding, like negation of an int literal can be replaced by just an int literal, which is a negative int literal, for instance. Like we can do those kind of simplifications, I think, as a first pass probably on the AST. Here, this is going to be, and that's just an expression. And this is again gonna be, I'm preemptively gonna decide that this is that, and we'll fix it if needed. Yeah, like I think different kind of optimizations can be done at different phases. I'm tempted to do the constant unfolding, yeah, as like a simplifying phase on the AST. I think it's just easier. Like it might be easier even than on the AR because since I'm aiming for a static single assignment AR maybe it's gonna be a bit harder to actually like see those patterns in the AR. So maybe constant unfolding I'll do on the AST. Like a thing I strongly recommend, especially for Haskell stuff, is like if some of those function like, yeah, but I don't have. I guess you're right. I guess you're right. I could probably have that constant unfolding both in the AST for like trivial stuff, and then a second phase in the AR that tries to see what can be simplified. You're right. It might be better to do it in like in the AR for those reasons. And like for the dot dollar thing, what I strongly recommend is just if you have any doubt, opening GHCI, trying things. So much of how I've learned to like do stuff in Haskell was like, I have no idea how those things work. Let me open GHCI and see how they combine, and like figure out like, hey, what if you use this operator on this thing? Oh, it type checks. Huh, interesting. What does that mean? And trying to figure it out. Like for instance, understanding the blackbird. SSA is just a binary tree. I will need to check. I'm not doubting this. It just I doesn't. I am not visualizing it, but I'm not saying that's wrong at all. I'll need to think about it. But yeah, back to the operator stuff. Like for instance, the blackbird I was showing in the prelude, it is obtained by combining the dot operator with the dot operator, and like yeah, that type checks. And understanding why it type checks, writing it by hand and trying to understand, I highly recommend it if you want to like develop an intuition for like how dot works. There was something else I had in mind about the thing about trying stuff in GHCI, and it skipped my mind. It's fine. It'll come back if it was important. Here, in both cases, we're going to be returning $1, which is the location of the token, and we're going to be returning a negation expression with $1 as the location there again, and with second of $2. Oh, yeah, no, I think that's correct. I've never tried writing anything in D. I've heard so many good things about it on paper, but I don't know anyone who has ever used it. I feel like it suffers a tiny bit from like an image reputation in some ways. Like it looks interesting on paper, and I don't know what happened with that language. Was it too early? Did it miss its window? Like I don't know what went wrong. it's among the languages like I'd like to try at some point. Maybe 1 year I'll do the Advent of Code not on stream, not in Haskell, and I'll try it in D. I'll go back to like Pony again just to see if it makes sense. Like there's so many interesting languages. Like maybe try Zig. I haven't tried Zig yet. There's so many languages I'd like to try, and D is definitely one of them just because like it looks interesting. And I want to go back to C++ at some point. C++ used to be my main language, and I haven't written anything substantial in it for a while. I kind of miss its jankiness. It's kind of weird. I don't know. It feels like Stockholm syndrome in some way. Like I've spent so much of my life debugging horrible things in C++ that now I like it. I don't know. I can imagine. I mean, I can imagine like all languages have their niche, right? Okay, so now we're moving on to arithmetic expressions. Which again here are like defined as a separate grammar rule, and I am gonna instead just inline here. So we have addition. Maybe addition is a better name. It's a better name for this, which takes two expressions. We have subtraction. Multiplication. Ah. That's the longest we have so far. Let's realign this. Something I find fascinating on this idea of like a C++ replacement, Go was designed on paper as a C++ replacement. That's fascinating to me. I have a lot of extremely strong opinions on Go as a language that maybe I'm not gonna voice too directly because they're mostly negative and I don't want to be rude. Uh, but the fact that it was intended as a C++ replacement was fascinating to me because in practice, it's mostly been used as a Python replacement. I don't know. Like at Google specifically, the rule was like like stop using Python for projects. Every project that was in Python should now be in Go. Basically, it was explicitly internally a Python replacement. Yeah, possibly. But like in its design paper, it's like yeah, we want something that has the upsides of the C++, but none of the downsides. We want a C++ replacement. But Go is a terrible language, so it doesn't matter anyway. I haven't tried Swift. There are so many languages I need to try. Exponent. What's the spelling of this word? It's probably in the reference. No, Go's error handling is horrifying. It's like, I mean, I don't want my Haskell streams to be derailed by talking shit about Go. But no, errors handling is not Go strong suit. No, absolutely not. Wait, it's not there? I thought it was. Ah, let me triple check exponentiation is the proper spelling. That seems to be perfect. Ah, yes. Well, I mean, Go's Go proponents saying this thing is good. Actually, they will say that for any part of the language, including saying like not having generics is good. Actually, it's a good thing. It makes the language better. When Go 2 was announced, with like now we have generics, a lot of them became very silent. It was very funny. Again, I'm gonna stop here. I don't want my Haskell compiler streams to just me be ranting about Go, but I don't like Go. It is one of my least favorite languages. How do I want to call this? Equals? 'Cause comparison is too vague. I think equals and different is better. Could probably generate this with like a small macro. I guess equality expression. Maybe that's better. We have greater expression. It's one of the things of like C++ evolution through the years has been very interesting. I've been writing C++ since 2007, 2000, yeah, maybe 2006. And yeah, 2006, I think. And it has changed a lot over the years, like the different standardization. Some of my early jobs were like not even using the 2003 standardization, so pre-STL containers, and like C++ nowadays has nothing to do with like pre 2003 C++ was. It's quite incredible how much it has changed. There are still like some of the standard library, the STL and everything, things that are a tiny bit controversial. I tend to like it overall, but not everyone agrees. But it's interesting to see, like, again, a Haskell victory there, where like all of the end then stuff is explicitly called monadic in the C++ documentation. I do like Rust. I don't have any professional experience with it. I only have personal like hobby experience with it. So I don't have large scale program experience with it. But the little I've done, extremely fun. I like it. It feels one of my only criticism is like it feels sometimes that like they're trying, it's like they're getting close to the Haskell thing, but they are limited by the language they have chosen, and they are trying to reach the Haskell simplicity and purity of things, and they're limited by the language they have chosen. The new try blocks, for instance, feel like, yeah, just give us do blocks, basically. But overall, no, Rust is great. I think Rust is fantastic. Yeah, I think, and I tend to be personal bias. Not saying this is the right opinion at all. Like, obviously, everything I've been saying so far, my opinion, and I'm just one person. I tend to be, I'm a Haskeller, I think it's obvious, very biased towards static typing and like the compiler doing checks for you because, like, I am one person with a brain that doesn't always work. Having a compiler that, like, is able to tell me when I do things wrong, great. Having assertions checked before runtime, great. Rust has this whole concept of like lifetime and checking the lifetime of things, which has a bit of like the same learning curve as like, oh, you arrive in Haskell, there's no mutation, how do I do anything? Working with lifetimes can be complicated in Rust, but the reward is when you get used to it, then suddenly you have like all those strong guarantees that like just remove an entire class of bugs at runtime, which is pretty neat. There is an article that was pretty great, which was like implementing linked lists in 20 different ways in Rust just to see what the impact is on like ownership and lifetimes. Linked lists are bad data structures, but the article is very good. So greater than, lesser than, greater or equals. Yeah, it's just the problem with linked lists is mostly like you get the pointer access for every time you iterate through something, and you are pretty bad at like caching because you it's hard to get like memory locality on something. But I mean, they have their uses. Okay, so that's it for those comparison expressions. Actually, I should probably go back to this and fix this while I'm at it. So this is going to be the same thing for all of them. So I can just copy paste here from the constructor list. It is those constructors. And for each of them, okay, so it's going to be a tuple with first of $1 and then this with second of $1 and second of $3. And I'm missing a closing parenthesis. There we go. Okay. And it's going to be the same thing here to the point that I could. I'm honestly tempted to just make a function with the constructor, given that all of them are going to be the same thing. Let me do an helper here, binary expression, which given a tuple location expression past another of those tuples will give me a tuple of location there is a concept that describes what we're talking about, and it's escaping me at the moment. The idea of indexing with. Wait, here, what did I want? Yes, I wanted something given two expressions. I could cheat and just write this over any E, basically. Given something that given two E's returns an E. So I don't need this to be specifically that feels ugly. I don't need to make this generic. Let's make this explicit. Actually, it's gonna also take the location. So that's gonna be the constructor as argument. And then the two tuples will return this. And so binary expression on a location, an expression 1, and another tuple, which is a location we ignore, an expression 2. And a constructor is that constructor on the location and x1, x2. There we go. Which means I can go back here and redefine all of this as being binary expression. The syntax highlighter is very confused by this happy file. I think it's because it's not highlighting for happy, it's highlighting for bison. And the small differences in the language make it extremely confused. And therefore here, $1 and $3. There we go. That's a lot cleaner. And here we can do the exact same thing. Again, jokes on happy write themselves. The documentation, like the official happy documentation, has a bunch of things about making happy happy because, yeah. And the only thing we're missing here are the constructor for this. There we go. Equality, difference, greater, lesser, greater or equal, less or equal. Perfect. Boolean expressions. Next. We're back to something that is no longer a binary expression. Okay, so let's write this as it is. Binary expression. And that's the Boolean thing. $1, $3 there again. Except here this is OR. There we go. Okay, next. We have cast expression. Which here is back to not just being a binary thing of expressions. We're gonna have, I guess, a type. Do we have any place where we have a type otherwise? I guess it's just gonna be a type expression now. Type expression does not give me a location, I think. Maybe we'll want to change that. I don't know. I don't think we need to. Where does type expression appear? In a bunch of places we've already resolved it. And yeah, here. So yeah, I think we won't get the location information. That's fine. So here we can go back to this is first of $1. And this is a cast expression with the first of $1 there again. And with, so the expression will be second of $1, and the type will just be $3. I'm pretty convinced that this is just going to be the type. We haven't defined it yet. It's here, so it's an empty type for now. That's one of the last things we're going to have to do when we're done with the expressions. And this is a tuple. It needs to be closed. There we go. Range expressions. We're getting close to the end. Like I'm wondering if this level of granularity is needed, and maybe we'll realize actually for expressions, except for maybe one or two of them, having an X expression instead is actually good enough. Again, this is something where like we will adjust as we make progress. We will see what our needs are as we make progress through the compilation phases. And the range expression is either an inclusive or exclusive. And that's two expressions. So this is a binary expression there again. Perfect. So here we can, that's also a location here. So that's wrong. I need to fix it. More location here and here again. Oh, actually, in this case, we are just gonna forward $1 because we have again. Do I really need to have this range inclusive expression and range exclusive expression as if they were separate things? Like this adds, this doesn't have add a lot of information. Maybe I'm just gonna simplify the grammar here and just inline this. And so that's two binary expression again. And that's again $1, $3. Okay. Assignment expression. God, that one is gonna be interesting. What do we have? Yeah, we have an expression on the left-hand side because that's something. Does the order of productions matter for conflict resolution? Only for reduce conflicts. Um, when like two different rules could apply, and like neither of them is a shift, like continue consuming tokens. We've consumed enough tokens, we could reduce using two different rules, which is like the very bad kind of conflicts you want to avoid. And in which case, then the order of productions in the file matters, and the first one will be chosen in case of reduce conflict, if I remember correctly. And I think that's the only case in which it matters. And we've removed all of them. We have only one shift radius conflict, and that's one we don't care about. Which means, in theory, at this point, the order doesn't matter. Sorry, no, there's one other case where the order matters. If you don't specify in the happy configuration which of the production rules is the one that is the top level one, that the outside function should be calling as like when you're trying to pass something, it picks the first one in the ones you've declared. We are explicitly declaring which one we want, so we don't care here either. But yes, otherwise, except it basically like doesn't really matter except for tiebreakers in rare cases. Here we have something that's going to be interesting. We are going to have in the language the notion of an L value versus an R value. I know Rust used to use a different used to use L value, R value, and now uses a different term for this. But basically, not all expressions will be valid on the left-hand side of an equal sign, but some of them will. It won't just be path expressions. Something like an array, like an index expression will be valid, for instance. Although most won't be, so it should be fairly straightforward. But we are going to have in the language that notion of L value and R value, even though it might be fairly straightforward. So that's assignment. And then we have the compound assignment. So that's going to be... How do I want to name those? I've made a choice so far in this project, and I'm going to stick to it, that I wanted to avoid one of the mistakes that a lot of Haskell programs make of abbreviating everything to the point of being unreadable. Let's be very verbose. I'm going to zoom this out a tiny bit for a second just to see what I'm doing. This might be a bit small on stream. I'll resume it back in a second. No R value references. I guess no, yes, R value references. Yeah, I guess. I don't think it's gonna matter that much because the way references are defined, they're defined on a path. You can only make a reference for something which is a variable name, basically. So we are not gonna have to worry too much about that kind of ambiguity. Okay, I'm gonna just vertically align all of that nonsense. Okay. Except this is not an assignment expression, this is an expression. Sorry for having it zoomed out, it's just I wanted to be able to see the structure of what I was doing. I'm gonna zoom it back in a second. Okay, so now that should be, I think, the entirety of our AST for now. We just need to finish defining those. Those are a bunch of binary expressions. Do I want to define plated expression? Probably. It might make sense to use the plated lenses expression since it's a self-recursive type. It doesn't make sense for all of the AST because it doesn't. Most of the rest of it doesn't have like self-recursion. For expressions, however, I think it does make sense. I might do that. This is all a bunch of binary expressions. And I'm gonna copy the constructors from here. Addition assignment, subtraction assignment, multiplication assignment, division assignment, modulo assignment, exponentiation assignment. There we go. Okay, so the only thing left to do is types. What a sentence. So what do we need in a type expression? Because I know for functions we have something. We have a function argument type that has by value by reference. Wait, where does reference appear then? Ah, here, okay. Okay, so here reference, we don't need to represent the type differently. The only case where it matters is handled by at this level. So here we only need to represent what is a type, basically, and a type expression is just a path. With generic arguments. I am not sure why I have it duplicated. I think I have it duplicated in the grammar because I wanted to be able to change one without changing the other, because they are fundamentally different, but in terms of like logic, they're the same. I'm tempted. I'm tempted to change. Since we already have a path info um, record here that has exactly what we need, I'm tempted to just say that for now, I think it's fine. A type expression is just a path info, basically. Which means I can go back to path expression. And I can copy this. And just check that it's the same. It's not the same because here it is type expression, but otherwise it's the same. Okay. And with this, we have, well, we haven't compiled, we haven't checked, it doesn't work yet, but in theory, we're done with the first draft. Whew. Which means we might be a way to finally move on from happy files. What again, what a sentence. I just need, for the things we have defined today, which is all of those, I need to get that. Go here. This is going to be replaced with type $1. P is a type. Ah. Yes, I forgot this. There we go. Perfect. And we're going to replace this with this. There we go. Perfect. That's all of the new extension types we have defined. Again, I have erred on the side of being extremely verbose because I don't know which ones we're going to need. And I would rather be very, very exhaustive for now. And if we don't need that level of complexity, we can absolutely simplify later, which I am planning on doing at some point. Now we can go back here. Expression. So here the thing I'm doing is I have this big list of type. Hello. I have this big list of like type of extension types again using the trees that grow approach. Again, a very long list because for now I am being very exhaustive. We'll see what we actually need. We probably will need a lot less than this gigantic soup. But for now, again, erring on the side of caution. And rather than having each of them be an independent type family, I group all of them in a type class, which is kind of not what type classes are made for, but it has a few advantages. One of them is I can group all of the type constraints I need on all of those types as part of the class constraint here, which means for my instances, I can then just use this class constraint and not have to reiterate all of those things everywhere. So here I have to go back to after expression. Perfect. And in the context of past, this is all gonna be location. Because again, for now, at every level of the AST, we are storing the location in the source file after parsing, but this is information that is not necessarily going to be relevant for a long time. So this is what we are currently storing in the extension types. Okay. Now comes the moment of truth. It is not going to compile on the first try, but let's see where it fails. Multiple declarations. Yes, probably. Aha, yes, because I have the X struct for the statement, and I have the X struct for the expression. I'm gonna here be explicit, struct def and struct exp, just to be clear, which breaks my naming convention ever so slightly, but I would rather avoid. Which means I need to do the same thing here. This is a struct declaration, and this is a struct expression. Whenever I find you or you here, which means this is a struct declaration. And finally, here in the expression, God, at this level of zoom, this is unreadable. Okay, next. Ah, yes. Do I have that typo somewhere? Because I absolutely might. Oh. Ah, yes. Yeah, again, when I was defining this earlier, I just zoomed it out just so that the structure would be obvious, which makes it a lot easier for me to see what I'm doing, but a bit less pleasant for the stream. Okay, so yes, that makes sense. Here in this thing, I've defined get int, get character, get string. I'm gonna say get int literal, get char literal. Which means I need to go back to here and expected one more argument to path info. Yes, those are a past path info. Okay. Aha, we got some tuple errors. Ooh, those are happy errors. So we're gonna have to go through the generated code. Fun. This is happy reduction 58. What is happy reduction 58? If we look at our grammar debug file, or yeah, I think it's the debug file. Actually, I should regenerate it since I've made some changes to. There we go. 58 is operator expression. Okay. Ah, yes, this also returns a location and expression passed. Expecting another argument to path info. Yes, I have more than one place in which I have made that mistake. Oh, oh no, I'm modifying it in the wrong place. Or maybe that was my mistake earlier. I modified it in a generated file, not in the happy file. There we go. Okay. And the first argument of uncurry. Ah, yes, yes. I see. My use of uncurry in the literals here is slightly wrong. Where are they? Here, because I also need to return the location, which I'm ignoring by doing this. That's annoying. Okay, so I'm going to do it. This is actually for all of them. A tuple that contains the first of the tuple, which is the location value. So we do that. Wait, no. What am I doing? No, that's correct. Yeah, that's correct. And here I'm going to have to do this. And the first argument is the location there again. So for all of them, so that's $1, that's fine. But for those, it is going to be first of $1 again. And then we are going to have those function calls here. And then we close double, which means I'm going to have to rewrite those functions. They're no longer returning the location and the token. They are returning. So I could probably rename them to be consistent. Yeah. Let's rename this one to be consistent with the others. Okay. And here we can rewrite them. They are now defined the same thing. We ignore the first argument, which is, so we can do this basically. I'm just gonna copy this part. That's enough. And finally, we need to change those return types. This is what we return. Okay. Pass error on input. Oh, in a generated file, that means I have a pass error in the Haskell code here, I guess. I must have made... Oh no. What have I broken here? Ah, yeah, I see some syntax highlighting. Aha, here. The tuple wasn't closed. There we go. That is indeed the wrong syntax. Okay. Hopefully that should be all of it. It is not. A few more issues between tuple of location and actual location, which was gonna be the problem anyway. Those have been my bane. Well, here, obviously. Let's fix that. This is location. And so is this. That's already a bunch of errors fixed. Okay. There's more of them. Okay, so which ones have I missed? I don't see any error in the return types, so this is worse. It means it's in the actual... It's in the actual expressions now. Okay. So, let's have a look. Happy reduction 74. What is 74? That's the literal truth. And literal false as well, probably. So there again, I have made a mistake. Where are my literals? They should be around here somewhere. There we go. So here there's a location and an expression. Oh yes, this is not first because this is just a location. Aha. Actual location path info. So I have something where it's the wrong type. And that's in reduction 49, which is... Huh. That's not very useful. So I have a second thing that is a path info at some point. But it seems to be in the reduction 49, which is just this expression. Oh, but maybe there's something I wrote last time and I haven't checked since. It must be here in expression statement. Uncurry expression statement $1, that's correct. I think. I'm gonna rewrite this one since I've changed the way I've been writing those. This is gonna be first $1 path expression, first $1 and second $1. Since this was a path, the error here is about a path info. There are very few places where we return a path info, so I'm assuming this is going to be one of those. No, I don't know. Oh, maybe it's for the type expression? No, that would be somewhere else. Okay. Oh, yes, actually, no, it's here. I'm returning the location here, which doesn't make sense in the context of a type info. So that's something we can change. And here that also means S3. Yeah, sorry, $3. I am tired. Okay. We still have this reduction in 49 that's wrong. Interesting. Ah, I have the lens that's wrong. That's easier to fix. So let's fix that. Let's fix that one. In the AST, I am making use of lenses, but there's a type for which I'm making use of it and I haven't defined the lens, and that's a for path info. So that's fixed. There we go. Couldn't match. Identifier with non-empty identifier. That's definitely my prepend function. Here, did I get the type wrong? Let's go back to this. That is the correct constructor, as far as I can tell. Oh, wait, no. This constructor modifies a list. This is not what I want. What I want is this one, which might not be imported. Variable non-scope. Okay, let's fix that. The lack of formatting is very annoying. This is data list non-empty. And I just need to import this operator. Okay, and we only have 2 remaining. Oh, I have a binary expression one that's wrong. That's interesting. So which one of those binary expressions is wrong? I'm assuming it's one where we don't have an actual expression. Those are all expressions. Expression, all of them. Hmm. Oh wait, it's the actual function that's wrong. Okay. Yes, this returns the location and this. There we go. Okay, we should have only one error left. Oh, we have more. Variable in scope location. Oh, because yes. Okay. So we have one place left, which seems to be in reduction 49, which is useless because it's just the top level. This is an expression thing where we have at some point a path info, but it expects an expression. So again, 49 is just an expression statement. That's not very useful. Oh, no, okay, this error isn't something else. It is in reduction 85. Oh, in the reference expression. Okay. Reference gives me a type expression, which I'm just forwarding unchanged. Oh, but in the reference expression, however, here, aha, this needs to return an expression, and I'm returning indeed a path expression. That is incorrect. This needs to be in the case of a reference expression. It is a reference expression with the location. So this needs to be a reference expression. At location $1. Now, that should be all. Okay, so the good news is now we should have something that compiles. Obviously, that means it works, right? Let's try. Let me move this where you can see it. I kind of want. Yes, I'm gonna do something, which means recompiling, but that's fine. Here in the question earlier of like, do the order of productions matter in the file? I was saying there's a few cases in which they do, but it's rare. One of them again is like, if I don't like give the name directive here, I'm saying like, what's the name of the function that should be created by happy that like exposes this module basically. And if I don't specify what production here is to be used, it uses the first one. And here I'm saying that a module parser is something that passes a module. I'm going to add that an expression parser is something that passes an expression. And in parser.hs, which is parsing.hs, which is here, I'm going to also add parse expression. Which will give me an expression parsed. And it's gonna still take the source path, I guess, and the actual raw thing, because that's easier that way. And I'll figure out if it makes sense to keep later. Okay, let's recompile this. Which means recompiling the happy file, which takes ages. Of course. I swear I can type. Okay. Reload. And now parse expression should be able to take some file name that I'm just gonna leave empty, or just like put interactive, and the text of an expression, and should give us the resulting expression. Let's try something simple at first. Let's check that precedence is working. 1 plus 2 times 3 plus 4. That's unreadable, but that's an addition expression that takes as a first argument on the left an addition expression? Wait. That takes the int literal 1. And on the right, the multiplication expression that takes the int literal 2 and the int literal 3. Yeah, no, okay, that looks correct. It's an addition of the addition of. Yeah, no, I think that's fine. So at the first glance, things like this look okay. Now, what we should do, we should commit this, and then we should write a pretty printer and write tests. Because we are hopefully done with the parsing for now. So let's commit this. I don't have much else to say. We didn't change anything. We didn't make any like major change to the grammar. I think I don't have to add a lot to this commit message because there is not a lot more than just that basically. But now let's do. Oh, I wanted to maybe write plated for expressions. Maybe next time. For now, I would like to implement. I don't think I want to implement it as show. I think I want to do it as a function that takes a module, returns a module. Or do I want to make it as a type class and then have each of those types implemented so I can have them pretty printed separately? I probably want the latter. Yeah, I think I want the latter. Although it feels like a very specific, let me think about this for a second. The upside of having one function is that I don't clutter the code with a bunch of different things that I don't need. It's just, here's the pretty print function, it takes a module and pretty prints the module. The downside is I'm not able to print small parts of a module for testing purposes. That being said, no, I think having the pretty print just being something that takes a module and returns a string, I think is good enough. I don't think I need to define it on a per type basis. I am going to need. Yeah, I'm gonna be using. Oh, because you're gonna be okay. Yes. I'm gonna use the text builder library, which I think is already included in my dependencies. Text builder, because I'm not gonna construct strings directly if I can just construct a text builder instead. This is also going to need a bunch of comments at some point. So pretty print. It's going to take a module parsed for now. We'll have to think about whether we want to just print. Yeah, I think for now let's read explicitly like this. And he's gonna return some text, and a pretty print is going to be running the run function. It is a builder, it's a monoid but not a monad, okay. And what are we going to want to do? Because a module is, let me open the same file here on the side. So that I have the reference for what I'm doing. Ah, I can't zoom one without zooming the other. That's fine. So pretty print takes a module as an argument, which is, I'm going to decompose like this, and is a run of tb intercalate with new lines, I guess, of what? Of map pretty print identifier. On the import path. Or do I do... No, let's do it that way. And map sorry, mod imports, wrong thing here. And pretty print declaration of the mod declaration. And now for the long and tedious process, what is pretty printing an import? Well, given some import like this, it's going to be it's gonna depend. No, the import type only defines how it's implemented at the end. I can do it without that, so it's gonna be an intercalate of this of the import path with then a case of import type of, if it's qualified with just a name, then that's tv text of as and print the identifier of the name. If it's qualified with nothing, then it's nothing. If it's specific with a list of identifier, specific. We're basically doing the inverse. After doing all this time parsing, we're doing something that reprints the AST. This is going to be... is there an isString instance, actually? There is, so I don't need to do this. I can just write directly this. This is going to be open braces, and it's going to be map pretty print identifier on the list of names, and then the closing thing. And if it's exhaustive, that is just a star. Wait, it's with this. This is this, and this is this. There we go. So that's pretty print of an import. Pretty print of a declaration. I should probably do a pretty print of identifier, which is actually for now just giving it a text, because for now identifier is just a text. If it's a type alias declaration, this feels like I'm not exactly a use case for plated, but I wonder if like this kind of traversal of the structure, would it make sense to make it some kind of like class for traversal? Yeah, I'm kind of, well, not type classes, but like the pretty print. But do I want to make a traversal kind of class of like, here is the callback for each at each level, and then have one function that does the tree traversal and calls the callback on each data structure? But maybe not. Maybe that's overkill. I will definitely want that for expressions, because that's basically what plated is in a way. But for the general structure, I don't think it makes sense. I think this is fine to just do it once. I'm just gonna copy paste. It's gonna be easier. That's a good point, actually. Will I need some? Will I need to some state to be carried for indentation? Not necessarily, because I can inline everything for the purpose of pretty printing. Um, well, no, actually, the statement level will need to be, you're right. But I can probably do that, given the very simple nature of my AST. I can probably do that just like an argument to like print statement or something. Or I can even do it by like modifying. I can probably do it without having to like keep track of a structure. Yeah, without any indentation, it would be unreadable. But I can probably retrieve the indentation without needing to actually like have some complicated structure. I've done this for my dot library thing. Um, okay. Next, what do we have? So a type alias info is going to be Actually, for declarations, no, I can put the semicolon here. Given some type alias info is going to be type the alias name. Again, there's a lot of things I have planned ahead of time. Like I know exactly how I'm gonna write the code when I reach that part. There's a lot of parts for which I haven't done the effort, so we'll see how some of the stuff goes. It's gonna be fun. The type parameters actually, it's gonna be interesting. It's gonna depend. So basically, it's gonna depend on whether there are some parameters. I guess I could do it without. I could say that it's always let's do things properly. Let's not take any shortcuts. So if there are no type parameters, it's just type the name of the type equals, and then I'm pretty print type expression, which I guess I can already. Nah, for now I'm going to do this that way. With the what is it? Alias value. And in the case where there are parameters, then we need to include this syntax. No, it's an intercalate comma of map print identifier on the alias parameters, followed by the closing bracket, and a space, and equals, followed by this. That's the alias info. That's done. What is printing an enum info? This feels. I'm not gonna lie, this part feels a tiny bit tedious after spending all of this time doing the parser, doing the reverse parser. In a sense, feels a tiny bit tedious. But this is the last stretch of being free of this. So I'll power through this. Then we can write some tests, and then we'll be done with all that stuff, and we can move on to the actual other phases than just parsing. So here, this is gonna be enum. Pretty print the identifier. If I do it with the type class, then I don't have to use a pretty print function like that. Yeah. But if I do it with the type class, I lose the ability to have a different function type per thing I'm doing, which I would kind of need if I want to avoid having to carry some state for indentation. Huh. Yeah, no, I'm gonna do it that way. I've started that way. I'm gonna finish it that way, and we'll change if we want to change later. But this is fine for now. Okay. That's the enum name. And then we have, what's the syntax? I think it's just open the braces. And then we do this same thing, intercalate of map identifier on the enum values. And then we close the braces. Oh, and the semicolon. I forgot the semicolon for the previous one. And I've forgotten it for here as well. You mean like having to write the parser, then the inverse of the parser, then the inverse and the inverse of the parser, as in a never finishing loop of writing the same code over and over again? Yeah, yeah, not wrong. I mean, I do like writing parsers. It's just like this is starting to be a bit big, and we've spent a lot of time on this. Hence, some tiredness. But parsers are fun. I will never complain about having to do parser work. I mean, I will never complain too much. I will complain, but what do we have here? This is going to be a struct. I don't remember. I don't think there is a need for actually this. I don't think there's a semicolon at the end of an enum declaration. There isn't, yeah. Okay, a struct then has. I can make a helper function there. I'm going to actually do that. That's going to be a bit simpler. I'm going to rewrite this as being this. And here, however, I'm going to do pretty print params. Not. There is printf. There is a printf function in the library which does kind of string interpolation. Here, however, I'm using a builder class that avoids unnecessary allocations for performance, and as a result, I don't think there would be an easy way for me to do like the equivalent of string interpolation for this. And here, so pretty printing a bunch of type parameters is just this. Which means I can rewrite this without the condition. Is always type the identifier, the parameters. Actually, this is open brackets. Okay, enum, that's done. Struct, then we do print the parameters of. Wait, first we print the name. Then pretty print the parameters of the struct. Then open braces. And I guess here I probably want to put it a line by line in a line by line way, although I didn't do that for the enum. Maybe actually for enum I want to do it that way as well. So this is going to be, I'm going to intercalate all of them with a new line. And each of them I'm going to do can actually put the comma here, and this is going to be 2 spaces before this for each value in enum values. It could be, but since by design white space doesn't matter, there is a sentence in the Rust reference I have copied, basically unchanged in mine, which is that like outside of string literals, you could change all of the white space and the behavior of a program should be the same. That means I can't guarantee like all in one line, a program would still be valid. So I can't just like decide on some random indentation and then check that the tokens match because it might not be the indentation that the developer had chosen for their own file. This is very unreadable at this level of zoom. I'm sorry. I could try. Let's try something. If I do this, okay, and then I go back here and I can zoom it out a tiny bit. At least now, yes, it's definitely a bit better. However, I lose my second window with what the types are. Okay, and now if I do this, this is starting to almost approach readability. So here we name the structure. That's a bit. Then we add the parameters, pretty printed with this. We open the braces. At colon 4 and the yeah, but again it could be at like colon 12 of row 16 and still be correct, given that like we do not have a strong link between where it was in the thing, and it's actually like indentation doesn't matter. So it might, but it might not. We can't guarantee, and as a result I don't think it's relevant information for us to like base our tests on. So here we're going to do the same thing. And what's the type of struct info? Those are tuples of identifier type expression. Okay. And what's the syntax? With a single colon. Okay. So for each name value in the struct values, we're going to be pretty printing 2 spaces of indentation. Pretty print the identifier of the name, add a colon, and pretty print the type expression of, that's not a value, that's a type. Okay, and we intercalate that with, no, so that should be fine. that's all for the. No, that's not all for the structs, for the constants. So the declarations. I am getting tired. You can tell by the fact that I'm saying more and more the wrong thing. Const info. That's the const keyword followed by pretty print the identifier, which is the const name, followed by this, followed by pretty print a type expression, which is the const type, followed by equals, followed by pretty print expression of the const value. There we go. Followed by a semicolon. Okay, next, what do we have? We have a function declaration, which is the last of the top level declarations. And this is gonna be a function, and actually I could segment that way. There we go. So this can go all the way to the top, and I can look up what a function info is. Perfect. There we go. So that's a function followed by pretty print an identifier, which is the function name. Followed by pretty print the parameters of the function, which are the generic ones which might not be there. Then open parenthesis, then I'm gonna make a separate function for that. So pretty print the yeah, this level of zoom is unusual. I'm used to it with the advent of code, but it's definitely not that level of zoom I use when I'm coding on my own. Although I've been tempted, and maybe I should do that. I should maybe sacrifice some. Instead of doing a bunch of things like this, I could instead write this as a bunch of concat and write it as a list of things to concatenate. With list fusion, it's gonna be fine. Yeah, it's probably a bit better. Let's do that. Which means I'm gonna replace all instances of this with this. Okay. And then you can see immediately where I got things wrong, so that's already helping. That's an mconcat as well. Actually, now that if I do this, then I can go back to here, I think. Because now I'm no longer using all of my screen space for this. Ah, yes, here it's wrong. That's fine. Okay. That's also an mconcat. And I think with list fusion, since I'm directly concatenating a list literal, GHC might be able to optimize this and not actually generate the list, which means we don't waste precious CPU cycles by doing this. Okay, const identifier column type equals value. Here we have the same thing again of this is a list. Actually, I'm going to rewrite it as a do block. Here, and that's okay. Which I could do here as well, which I might quickly. So for each value in enum values, pure of this. Okay. Now, for a function, what do we do? So this hasn't changed. So I'm going to delegate to a separate function. Do I actually? Or do I not need to? Yeah, let's delegate to a separate function. That's fine. We close the parenthesis and then it is a monoid, so I can do a fold or a fold map or something. Yeah, I can do a fold map. Since here I have a maybe type expression, I can say what to do in the case, what's the monoid to output in the case where there's something inside the maybe. And since it's a monoid, it can just use MMT otherwise. So that means in the case where there is a type, what I want to do is pretty print the type expression after an arrow. And then I open the braces. And then what do I do? I'm going to go pretty print the statements one by one by line. And this is where I am going to start having to thread. Do I do it like in a monadic way, or do I just give a function argument? I don't think I need anything else than that, so I'm going to do it with just a function argument for now. I'll change if I need to do more. So now this is going to be, I'm going to be basically specifying the indentation level. I'm going to go print a bunch of statements at indentation level 1. So this is going to be separated by a bunch of new lines. Map of map preprint the statement at indentation level 1 of the function body. And when I'm done with this, I will print a new line and the closing brace. Okay. Now, what do we do next? We've done all of the top level declarations, so we're done. So now we move on. Nope, I forgot function arguments. Which are just comma separated things, which are in turn for each name in my language. No, they're not. So we don't need to worry about this being the wrong level and having to refer to the function level, because no, there's only top level functions. Name and type expressions. Oh, well, function type, arg type. There we go. For each of those in the function arguments, we are going to want to print. This is an identifier. Followed by the colon operator, followed by printing the type expression of the arg. Well, no. If it's by value, then pretty print the type expression that's given there. If it's by reference, do the same, but add the ampersand before. Okay. Next, we're done with all top level declarations. Let's move on to statements. They're already sorted by line. I don't need to do anything in terms of new line or line manipulation there. I can just say that it's a... Oh, and there's the level of indent. Oh, actually, I don't have to do the level of indent thing, I think. I think I can be smarter than this. Yes, here, if each statement is put on its own line, it is enough to do for each statement, yes, in the function body. I will output 2 spaces at the beginning of pretty print the statement of that statement. And now, as long as within that statement there is proper indentation, that should be fine. So now printing a statement is just a matter of do that again. So if it's an if statement, Pretty print the for information. Which means if I do it that way with the space added afterwards, I could make it a type class instead rather than typing all the names all the time. Oh well, I have started like this, I can finish like this. While statement. Yes, but that would probably require manipulating, like going through. You have no guarantee that it's going to be converted at runtime with like an actual stack like this, so it might not be reliable. But here, but yes, in principle, doing some like live introspection of the runtime to figure out some information, fun. Don't let me discourage you just because I'm nitpicking edge cases. Well, statement, let statement. I'm just gonna copy paste it. It's gonna be easier. We never care about this for the purpose of pretty printing. Um, a continue statement I can already do because that is simply the string continue semicolon. Likewise for break. And for an expression, that's just going to be pretty print the expression and add a semicolon. Now we're left with left and return. For let is going to be print the let info. But for the return statement, I can probably just inline it. It's return. Fold map there again of the return expression, if any. Where if there is one, this is a pretty print expression to which we add one space, I guess. Yeah, there we go. Now, whew, I am tired, but and it's already been 3 hours. But we're so close to having something that's somewhat decent that I want to push through this. Just because it would allow us to move on to something else next week, or sorry, on Thursday, which would be nice. Have I been? Yeah. Okay. I'm consistent in my naming. So pretty printing this is going to be there again an mconcat, and it's going to be an if followed by printing the expression of the if followed by opening the brace and putting on a new line. And then we're going to do the same thing, which is for all the body of the thing, we're going to intercalate with new lines and add spaces. So basically the same thing as this here. I could make a separate function for this, actually. Yeah, it's fine. Okay. And here we need to decide how to pretty print the else, if any. Except, yeah, it's going to need to be prefixed by this. There we go. If there is an else part to this thing, then do a fold map there again. Okay. If it's an else if, then just print the if info inline directly, except with a space first. If it's an else block, then we just print the open brace, and then we do the same thing there again. No, I don't think so. Because it would be an else if and then aligned at the same level of indentation. I think that's fine. Because if I were to put the if on a new line, then else if, like, yes, it would need to, I would need to indent more. But since I'm putting the, but no, that's fine, because the statements of the within the if, I print them and then I indent them, and then the if itself will be indented, so they're gonna be pushed. So far we don't have a problem of indentation. We might run into it, but so far we don't yet. Because here in the body of the if, I am doing this. So if it contains an if, I'm gonna move everything further. I am applying the indentation on the result of the recursive call. Oh, no, that works. Yes, that's fine. And not making the mistake of yeah, no, that's fine. I'm calling the statement and I'm applying a result on it. Yeah, I should be fine. No, it's not. You're right. I'm wrong. Because all of those functions are giving me not a list, but a single builder. So here I'm applying this indentation on the first line, not on all of the lines of the thing within the statements. So nope, you're correct. This doesn't work. Um, so I need to rethink this. Either I make everything give me lists, and that way I can do the same logic where I don't have to keep track of the indentation level, which is probably what I want, because I like this idea of recursively indenting the things that are given to me and not having to keep track of it. So I am probably going to do this. I think it's fine for all the top level things to not return a list. However, for statements, for any statement, which is anything which has a group of um, Yeah, for statements, I will want to have something written me a list, which means now that I have, okay, I'm going to make a separate function for this. So given a list of statements, how do we print them? I think there's never going to be a list of statements which is not open by. And we want this to return a list there again, because we want to be able to indent this thing. But it needs to be a line per thing. So that's fine. But that means, okay. So if I have a list of statements, this is going to be a list of indented. Okay. So if I do a concat map of print statement on my statements, which I can probably point through this, then each of them gives me its lines that I assume are probably properly indented recursively. And then for each of them, I indent by 2 spaces. Okay. So here that's fine, and I can do a intercalate with new lines of the pretty print of the block of the function body. And here, however, within the statement, I cannot do that anymore. Because here I have to be returning, all of this now have to return a list of the different lines. So that's one here. So that they can be indented recursively properly. This is an expression that's just a line expressions. I'm not going to be breaking down into multiple lines. There's no reason to do that. And so for an if, this is no longer an mconcat, this is a list of lines. The first line is going to be the if, which I can do with an mconcat. Then my other lines are going to be actually it's going to be this list followed by the list of doing pretty print of the block of the if body. So get the list of 8 statements, indent them recursively, but this time we get the list, so that's fine. And this is followed by another additional line, which is the closing brace. Okay, so that means I cannot put the else on the same line. No, I can do that actually. I can do that because here at the end, the last line depends just on the else info. If it's nothing, our last line is just the closing brace. If it's just an else if with an if info, then we are going to return the exact lines of the list info that we're going to add, unless we don't bother with this and we just always add it on the next line. No, I think it's better to just add it on the first line. So here I'm gonna give an actual additional information to the if info, which is what to add on the first line, which is empty when we just encounter it as a statement. And otherwise goes here, prefix. And in the case of a just else if, we pretty print the if info again. But this time we prefix with this on the first line. That's still a list of lines, so that's fine. And otherwise, if it's just an else block, what do we do? Actually, this is the prefix. This is an else if. And here, this is just this. And here in this case, it's this line at the list of the beginning. It's this list of one element before pretty printing the block B, before adding another line, which is the closing, brace. Okay, now this should be fine. Definitely going to test this, but I think it's fine. I just need to remember that statements need to return a list of lines rather than to return one builder, which is fine. Next, we have a for info. Where what we do is we return a list of lines there again. And the first one is the one that we're going to do with an mconcat, because it is for, followed by printing the identifier, which is the for variable name in pretty print the expression here. And at the end of this first line, open the brace. And this first line. So the thing is, like, now those functions no longer give me an actual string. They give me a list of lines, which means the list of the here it's gonna be inserted when I do the intercalate here. At the top level, module level, here those functions give me lines, and therefore there's no need for me anymore to actually I could do this as an mconcat, because I'm concatenating lists here, which is why I'm back to this idea of doing the indentation recursively. I don't know if it's better. I don't know if this is better. Because this needs to be, maybe it's better. This is my first line. So it's my first group of line that happens to be one line, which is an mconcat of this stuff. which is then concatenated with, I should probably indent this as well, there we go, which is concatenated with the next group of line, which is pretty printing the block of the for body. And finally, at the end, one line, which is the closing brace. And that's my list of lines. Okay, next, what do we have? While info, which is going to be somewhat similar. Oops. Because we have our first line, which is while, and it's just an expression this time, so it's a bit easier. While exp, and then here print the body. And then one group of line, which is just a closing brace. Okay. What do we have then? We've done if, for, while. Let is the last one that we have to do. And then we can move on to expressions. So a let probably doesn't need to be, it's probably going to be only one line. Since I'm planning to not break my expressions into multiple lines, this is just going to be one line, which is going to be an m concat there again, just to use to put the list of things I want to concatenate. This is going to be let print the identifier of the name. If there is a type information, pretty print it. And then add this before. But that's only if there's one, otherwise do nothing. Then add equals. Then pretty print the expression, which is the let expression. Again, assuming it's all going to be on one line, so that's fine. And then the semicolon. Okay? That's all for the statements. So now everything should be fine. We just have the expression type to do. Okay. Let's do this. Just gonna copy paste the constructors to avoid having to type them again. And I think that we're just missing the type expression, and that's it. We're done. Okay, and then for on each line, just gonna do this. A bunch of spaces followed by parentheses and x and a bunch of stuff are gonna all be replaced by this E1, E2, and it's going to be, in most cases, open parenthesis, pretty print the expression E1. close parenthesis, some operator that I'm gonna have to define, open parenthesis, print the expression E2, close parenthesis. Okay. Now, to align this a tiny bit better so it's readable, and maybe go back to here, remove this. Oh, wrong direction. Put this back up a bit. Good enough. And fix this. What's a path expression though? Oh, I think it has a path info, so I'm gonna need to do something separate here. Oh, absolutely no worries. And perhaps I did. Let me check. Sorry, I didn't see your message. Instead of if body. Yes, you're correct. That is absolutely what I meant to write. If body will be the lens when I have created the lens. With the underscore, it's the field. Thank you. You saved me some time in type errors later on. Actually, I should probably... Okay. E2 space star is just E2 space. And now I can realign this on underscore. Okay. I think the path expression is different. What's in it again? Yeah, it's a path info, so I need to treat this differently. There's a few that are different. So those are gonna be, so it's gonna be a pretty print path info, I guess, to be consistent. Okay, what we've done so far. But for most of those, this is fine. I just need to decide what the operators are. This is the exponentiation assignment, modulo assignment, division assignment, multiplication assignment, subtraction assignment, addition assignment, assignment. Range exclusive is this one. No, it's the other way around. This is the inclusive, it's just the exclusive. A cast expression is as. Oh, but it's different. I'm gonna move it because the second part is not too purgatory with you. The Boolean or the Boolean and are indeed just expressions. So there, that's that. It's fine. Lesser or equal, greater or equal, lesser, greater. Difference, equality, exponentiation, modulo, division, multiplication, subtraction, addition. Oh, ha ha ha. Here we have lost some information in the parsing. Again, the AST is not bidirectional. The negation expression is either a Boolean not or an integer negation. And it could be either. It's fine. Like it's a negation. We don't have a different representation in the AST for like to differentiate them basically. And as a result, here when it's time to pretty print them, we don't know how to pretty print it based on the type of the expression because we don't know what the type of the expression is. So here we're just gonna have to decide which one we want to do. And I'm just gonna say I'm just going to say this one actually for differentiation, but it might not be correct. So here is again a place where we have lost some information in the AST. Yeah, I guess negated as an argument is not the worst. Actually, this is also one of those which is not. I think that's the end of the binary operators, so I can leave them separate with their clean pattern here. And now I can do the ones that are not, which is all of those. So negation. Yeah, I guess negate as a function call. Should be just E, I guess. A reference expression likewise is a unitary thing, and it's just this. I guess I could even just tie it together like this. A string literal doesn't need parenthesis. Oh god, I'm gonna have to do string escaping there. Oh, I don't want to do that. Is there a way in data text? What's the show instance of text? Let's try. I'm curious. If I have something that contains a few backslash n's, which happens to be of type text, if I show s, wait, what? Yeah, no, okay. Oh yes, because I did a show of S and it gives me a string, and it does a show of the string. Yes, if I just do S and it gives me a show, yes, okay, it does some of the string interpolation for me. That's gonna be good enough for this evening. So that means that for a string literal, which is text, if I show a text, if I show it, and I do a TV string, I should get some of the escaping correctly. For a character literal is going to be just this followed by just the character followed by this again, which I think again is going to do the right thing in terms of escaping. Int literal is going to be just show the integer, I guess. Not gonna bother. A Boolean literal should be a lowercase version. So again, create the string builder by doing a map to lower of show of the value. I could also just okay, I could just also, rather than doing string manipulation, there we go. Aha, struct expression. Do I want to make, no, I've said that I didn't want to make any new lines in my expressions. So this is going to be all inlined. Um, and I probably don't need parentheses for a type expression. But I probably want, no, I probably want them just for clarity. Okay. Field access, print the expression, and then it's an identifier, I think. So it's just a call expression is where all of those parentheses are going to be very hard to read because this is going to become, I think call expression is different. Let's do the others that I know. An array expression is going to be, I think it's just a list of expressions. Oh, actually, something I didn't do earlier. No, I did. Okay, perfect. Okay, what are we missing? Indexing expression. Okay, that is because it is a expression underneath. So I am, since everything is just everything is an expression, I'm gonna put between parentheses. That way the since the parentheses information is lost at passing time, this is the only way to guarantee that the precedence I print is correct. In case of like field stuff, it's unlikely to have real precedence issues, but that way I can also check that the associativity of field access and other things like this is correct, because then the parentheses will clearly show the associativity in the output. So I am erring on the side of parenthesizing everything, basically. An index expression here is going to be an expression on the left, so it needs to be parenthesized. And then it's going to be with brackets here. So I'm missing, what am I missing? I'm missing the struct expression. I need to check what the types are. The call expression, and I need to check what those are. Oh, references to path info. So for structure expression, it's path info, and then it's a list of pairs identifier expression. Okay. Index, we're good. Array, we're good. Call, it's a list of expression. Okay. So call expression, this is the same thing. It's the expression that gives me the function on the left-hand side, and it's the args afterwards. So that's that. And then it is just directly parenthesis, which is kind of ugly. And here it's going to be an intercalate of this, of map print expression of the arguments. And the struct expression is a path followed by open braces, close braces, and it is It's a complicated one. It's an intercalate of, for each field, we're gonna be doing wait, I'm not sure for the struct expression actually. For a struct expression, it is field expression. It's also with colon. Okay. Yes, this is going to be extremely heavily. I have an example actually. If I go look here in the documentation, in the reference, where is it? There. Precedence. I have this absolutely horrible example here, which I'm gonna try, which is here presented with like full parenthesization to make sure that it is very explicit. Which here is a tree that represents what this expression here passes into. So that's gonna be an example we can try. So structures are pairs of identifier expression. Okay. So it is indeed identifier name. They print expression value for each name value in the fields of the structure. Okay. And with that, I think that's everything. We just need path info and type expression, which is just path info for now. We have cast, we have field, we have call, we have array, we have index. Okay. And at long last, what is pretty printing? Pretty printing. Oof, I am tired. A path info. What is a path info? Is name and parameters. Would the intercalate in this thing? It takes a foldable. Perfect. So I can call it on a non-empty list. I don't have to transform it to list first. That's good. Okay. And then I guess I can do a pretty print parameters as well there. Why are those? Why are those parameters? Ah, no, they're type expressions. That makes sense. No, that makes sense. That's correct. I copy this right with me. So this is gonna be an intercalate with this of a map of pretty print the identifier of the path name, and then a fold of I can do it differently. And case the path parameters if they're empty then nothing. Otherwise it's going to be open the brackets. Actually, no, I think it's with this. Again, let's check parser. Where is that? Yes, it is with it's that syntax, followed by for each parameter, which is again a list of type expressions. This is going to be a tb intercalate comma of map pretty print type expression of path params. And there we go. That should be everything. Whew. Could not load text builder. That's an easy problem to fix. That just means that in my package description, I don't have the dependency there. I probably have it elsewhere. Yeah, it's here. I'm just gonna remove it and put it in the general library. Record wildcards may not be used for constructors with unlabeled fields. That's because that's function dec is incorrect. It's function info. Oh, also, I'm missing something here. This is use followed by this. Okay. Names. Oh, const info. I forgot const. Oh, I named it const dec instead of const info. There we go. That's okay. I think that's incorrect. What's an import again? It is import type is what I wanted. Okay. Oh, and this is also probably actually a map pretty print identifier. Okay, so expecting a list. Expecting a builder got a list. Yes, this needs to be comma separated. Bunch of small mistakes that we're just gonna quickly yes, here again my naming convention is wrong. Hmm. Oh, because here it's a T intercalate, not a TB intercalate. There we go. Guess there's going to be a bunch of errors, so might as well recompile. Same here. Yeah, this is Manjaro Linux. Well, this is Emacs full screen in Linux. Well, actually, this is Emacs full screen in Linux being captured by a capture card, and then on the OBS running on Windows, the composition is done with the camera and the sound to then stream to Twitch. But yes, except for the camera and the compositing in OBS, this is Emacs running full screen on Linux. With just like, I have my why this distro? I used to every time I would install a new laptop, I would try a new distro, as a matter of principle to try a bunch of different things. And I've tried a lot over the years, but in recent years, I've erred towards simplicity. And a few years ago, I had tried Manjaro when trying a few of these new ones. I had tried Sabayon, which was a something based on Gen 2. I had tried Mint, and then I tried Manjaro, and it's basically the one I stuck on of like, okay, well, new laptop. I don't want to redo everything. I'm done with trying a bunch of distros. This one has been working very well for me. Just Manjaro, which is basically a layer on top of Arch, I think, mostly. But I don't need much. I need basically I since I use Linux as mostly as my work laptops. I need in my Emacs full screen, my terminal full screens, and the Firefox. Oh, that's a good question. I don't know what the current state of Linux distributions is, so I'm not sure I can give a good advice on this. For a long time, the Ubuntu series were like known to try to be pretty decent for beginners. I don't know if that's the case at the moment. So yeah, I would not feel confident giving you a recommendation because again, I have not kept up with recent Linux distributions. What I would recommend is if you know anyone in person who uses Linux, use the one they use because then you have someone you can ask questions to directly. And that's the reason I started with Gen 2 when I started was because everyone around me at the time used Gen 2. Therefore, I had a bunch of people I could go to in person to ask them what was broken with mine, and that was just like the easiest. Arch has some downside, but has some pretty good documentation, which is pretty decent. But yeah, my biggest recommendation is use the one that people around you use. Basically, I have never used Red Hat, so I cannot recommend either for or against. We were finishing to debug a few things because I wrote this gigantic function in one go, so now I need to debug everything. I have a few places where I have T intercalate instead of TB intercalate. Might as well try to see if I have any others. I don't. That's if body, not if else. Up, there we go. Um. Wait, no, this is if exp. There we go. I am tired. It is time for me to finish this and then go to sleep, go to bed. Again, so here, what I'm doing is I'm concatenating lists of builders, so it needs to be this. The most cursed thing I've ever seen was ZFS on FreeBSD, I think, or something like this. There was a combination of like FreeBSD, some weird file system, I think the NTFS port or something, and it was just completely, it was like hiding some files and overriding some others. It was a complete nightmare. Here I'm going to redo it with the mconcat just to be consistent with how I've done it everywhere else. So the first group is this, the second group is this, the last group is this. Okay. Yes, that's the in a while info. That's a while info, not a for info. The number of errors is diminishing. We'd like to see it. Oh, yes, this is a path info again. This needs an argument. Oh, actually, what's the show instance for a character? So if I do see, sure, it does. Okay, so I don't need to do that. I can do the same thing here. I can do a okay. Import is unused. I like those errors because they only happen when everything else works. Okay. Name shadowing. What do we have? We have name shadowing now. I have already another. I'm just gonna name it. Okay. Okay, so this compiles. So now let's try to write small programs with this. I'm gonna try something. Let's try this. I have here a very small file which is supposed to be the main for at some point our compiler that calls into the library. I think for now what I'm gonna do is I'm gonna ignore this. Um, wait, what's the function for? I want to read the inputs. Did it get contents? I think it has some lazy IO which has some problems, but get contents. Which is fully read from before being returned. That's what we want. Oh, actually, we probably want not to use this, but there is data text IO since we want text. There you go. Get contents. So what we're gonna do is we are gonna get the entirety of the source from the standard input. Is it called? Yeah, it's get contents. We're gonna then get the so parse module interactive of the source and on either M, I think that's how it's called in my prelude. On left. On left. So I have some either EA, and I give a function that returns. Yeah, perfect. On either, for now, I'm just gonna ignore the error and just const help. There we go. And that gives me the AST on success. And now that we have the AST, what I can do is I can do a put strln of pretty print. How is our function called? It's called pretty print of the AST. Hiding get contents and put str. Okay. Oh, interesting. So that means here in this file, yeah, I forgot to do. It's supposed to be the big module that includes everything, and I forgot to put the base things in there. There we go. Oh, that's not the proper syntax. What I want to do is I think this is the syntax. Let me check from the prelude. That is correct. And it's on left, as we have discussed. Okay, now we have a small program that tries to get some program from the standard input and then parses it and pretty prints it. So now we just need a test file, which is going to be, for now, let's try simple. This is going to be a function main with no argument that does return 42 semicolon. And let's try stack run PC, and let's give it as input this. Okay, so it printed this, which is ever so slightly incorrect because it includes the type arguments here, despite the fact that main doesn't have any type arguments. So we can go fix that. So that would be in the pretty print of function info here. Oh, yes, of course. That was the whole point of making a separate function, is I could do something smarter, and I didn't. Where are you? You're here. Here I can say that if it's empty, then that's empty, and otherwise there we go. So now it's printing correctly. Let's try with a more ambitious file. Let's try the nesting. So I have if true, if false, if 42, and let's try some complicated expressions. Print, which is a function that doesn't exist, but it's fine, so it should be passed as a call. And let's try a times b plus c minus d divided by e to the power of f modulo g. Semicolon. Let's try. So the indentation is working. I'm happy with that. if true, if false, if 42. Print is the function. This is the call. And is that correct in terms of... Is this correct? It looks correct in terms of nesting parentheses. But this is unreadable. But it looks correct, I think. Because we have a ton of parentheses here. This is the whole thing for the minus. Yeah, I think it's correct. Okay. I am moderately happy with like this gigantic function that I've been like struggling with because I'm tired and I've been streaming for 4 hours, working basically first try. That's pleasant. So here, let's try a few more things. Let's use foo bar star, and since I want to test that spaces are not significant, let's switch a bunch of spaces. Use base A, B, C. Use I have no idea for names. I am tired. F as G. Let's try a constant declaration. Const answer is, it needs a type, that's an int, is 42. Let's try an enum declaration. It's going to be red, green, blue or something. And let's try a struct, which is gonna be a customer with a type argument t, and it's going to be a unique ID of type t. There we go. Okay. Use foo bar star semicolon base abc f as g. Const answer is name 42 enum color that has been in line, and this like it has even removed, it has done the intercalation wait, how did it do? Oh yeah, no, that's fine. Yep, the commas are correct as well. Customer is indeed parameterized by t and is a unique. Yeah, that's. I mean, if it compiles, it works. But apparently, except for the function arguments, because let's be honest, it did not work first try. But except for that, it seems to be working more or less. Which means now, although I might not do it today because I've been streaming for 4 hours and my brain no longer works, we can add tests to this because we're done with parsing. Parsing seems to be working, and we can start adding some canonical tests to make sure that to start building a corpus of tests, because I'm sure there are some weird edge cases we haven't found, and it's going to be important to test all of them. And we can start doing a battery of tests and making sure that we can also do a thing where we can do some round trip tests, except for negate. Except for negate, I can do something where I generate a random AST, I pretty print it, and then I try to pass it back. And that should always give me the same result. Because even though the AST is not bidirectional, what I pretty print should be correct. And actually, I'm just going to make it so that when I do pretty print and negate, I'm going to always do it with something that would pass back as a negate. Therefore, here, I'm going to do it with this. That way, I can try round trip tests where I can make arbitrary generated tests of the random complexity that generate a random AST, pretty print it, pass it back, and check that there is never a case where we pass it wrong. And if there is, we'll figure out why that's that, and if that makes sense, if there's any ambiguity in the thing, yeah, exactly. I'm gonna make some quick check tests of making arbitrary ASTs, I think. But I'm not going to do that today because I am exhausted. So let's commit this, and then I'll stop here for the evening. I might not actually commit this, however, because this small program is not what the compiler is supposed to be. I think I'm going to keep it locally and use that for when we make tests. I don't think I want to commit that to the repo. So I need to change this, and this, and this, and this. Oh, okay. And now we are free of Alex and happy for a while until we go back to fixing the absolutely horrible or error messages we have at the moment, until we go back to improving our location spans and everything. We're free of Alex and happy, and we're back in Haskell world, and we're gonna stay there. So yeah, on Thursday, I haven't updated the Twitch calendar. I'm gonna do that next. Thursday, 8 p.m. UTC, same thing. Wait, are we still in UTC here? Time in UTC. We are still in UTC here. So Thursday, 8 p.m. UTC, we're gonna start by adding tests, both some canonical tests, some golden tests that I can regenerate, and some quick check tests where we generate arbitrary ASTs and test round trips. Because at this point we can do that. And either I'll move on to some of the AST manipulation stuff, like doing renaming, type checking, and so on, or maybe I'll take a detour and do some of the bytecode stuff for the image generation part, so we can actually generate some Piètre programs and see how they work. I'll see what it's like on Thursday. For now, it's time for me to go sleep. Thank you for tuning in. That was a fun one. We've made a lot of progress, and I'll see you next time.